10-1, the Pythagorean Theorem. You may have heard of this theorem before in previous pre-algebra and so on books, but today we're going to look at it in the form of algebra. Before we look at the Pythagorean theorem, we have to look at the two parts of the triangle that we're going to need. The first part is the hypotenuse. The hypotenuse is the side opposite the right angle in a triangle. It will be the longest side in a right triangle as well. The second part are the legs. The legs are the two sides that create the right angle. They will be the two shorter sides in every right triangle, and they will always form a right angle. Those are called the legs. What really is the Pythagorean theorem? Well, the Pythagorean theorem relates the length of the legs and the length of the hypotenuse in a right triangle. And we will use this theorem to find missing lengths of sides of triangles. Now, what does the Pythagorean theorem actually say? It says that in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. This can be written a squared plus b squared equals c, because in our triangle our two legs are a and b and the hypotenuse will be c. And what the Pythagorean theorem tells us, that the leg a squared plus the leg b squared is going to equal the hypotenuse c squared. Alright, now let's put this to use, finding the missing length in this triangle given here. What is C? We're going to look, our two legs are 6 inches and 6 inches. So we're going to use our formula, a squared plus b squared equals c squared. So when we apply that, it'll be 6 squared plus 6 squared equals c squared. Now when we square both of our 6's, we'll get 36 plus 36, which will give us 72 is equal to c squared. And after we get that, to find c, we take the square root of 72, and we end up with c being approximately 8.5 inches. Here's another example. In this example, our sides, or our legs, are 9 centimeters and 12 centimeters. What is our hypotenuse going to be? Well, we need to set this up the same way, using a squared plus b squared equals c squared. So we will get 9 squared plus 12 squared equals c squared. So we get 81 plus 144 equals c squared. When we add those together, we will get 225 equals c squared, and then we'll take the square root to get c, and c will equal 15 because the square root of 225 comes out to be 15. So our missing hypotenuse will be 15 centimeters long. Okay, here's another example. In this example, we are going to be finding one of our legs rather than our hypotenuse. How can we find B instead of finding C? When we want to find B instead of C, we're going to set it up the same way. We're going to use a squared plus b squared equals c squared. But instead of having everything equal what we're looking for, we're going to have what we're looking for right in the middle of our equation. So in this instance, we would set it up and it would be 5 squared plus b squared equals 13 squared. Now it just comes down to algebra, which you have all done before, and I know that this will be a breeze. So we'll square these out, and we'll get 25 plus b squared equals 169. Now we need to subtract 25 from both sides. So we'll get b squared equals 144. And then to find b, we will take our square root. So b will equal 12. One more example in this form. Now in this one we're going to be finding a squared instead. But we're going to set it up the same way using a squared plus b squared equals c squared. In this case, since our a's are missing, we will just have a squared, and then our b will be 12 squared, which is equal to 15 squared because our hypotenuse is 15. So now when we square it out, we're going to get a squared plus 144 equals 225. Now we just go back to our algebra and we're going to subtract 144 from each side. So we'll have 144, so a squared equals 81. And then we take our square root and we will get a equals 9. Okay, the next thing we're going to do is we're going to look at identifying right triangles. We're going to be able to use what we know about the Pythagorean Theorem to tell us how to identify right triangles. If a squared plus b squared equals c squared, then the triangle is a right triangle. So by plugging in side lengths of a triangle, we'll be able to determine whether or not it is a right triangle. For example, which of these is going to be a right triangle? A triangle that has sides 6 inches, 24 inches, and 25 inches? One that has 4 meters, 8 meters, and 10 meters for its dimensions? Or one that has 10 inches, 24 inches, and 26 inches for its dimensions. Now to figure this out, we're going to go through and plug each of these in for the Pythagorean Theorem and see which one works out. First, we have 6 squared plus 24 squared equals 25 squared. So we would get 36 plus 576 equals 625. No, that doesn't quite equal. So we know it can't be that first one. What about the second one? We'll get 4 squared plus 8 squared equals 10 squared. So we'll get 16 plus 64. And that does not equal 100, which is what 10 squared would be. So hopefully this last one will work out and we'll be able to find a right triangle. So we'll get 10 squared plus 24 squared equals 26 squared, which will give us 100 plus 576. We get 676, and that works out. So therefore, the third one, the triangle with sides of 10, 24, and 26, is a right triangle. Okay, one example using what you just learned is the triangle with the sides 20 millimeters, 47 millimeters, and 52 millimeters, a right triangle. We're going to figure this out by plugging it in for the Pythagorean Theorem and seeing if it works out. So we'll get 20 squared plus 47 squared equals 52 squared. So 400 plus 2,209, is that equal to 2,704? No, it's not equal. So that means that these dimensions are not the dimensions of a right triangle. And that concludes lesson 10.1 on the Pythagorean Theorem.